Question 2. In this question, we've been told that minus 2 is a root to this equation, and we've got to find the other root. So if minus 2 is a root, then we know that when we factorize this, we're going to get z plus 2 and something over here. In order to find that, this is like single math, like what we do in single maths year 1, chapter 7. We're going to do some long division. Make sure you put the z squared in, just to avoid making any silly mistakes in there. And then we're going to divide that by z plus 2. When we z cubed divided by z is z squared. Multiply that, you get z cubed plus 2z squared. Subtract minus 2z squared. Bring down the plus 6z, and some people like to bring down the plus 20 as well. It doesn't make a difference. Start again. Divide. You get minus 2z squared minus 4z. Subtract that, and you get 10z plus 20, which then, if you divide by z plus 2, you get plus 10. And that works out with no remainder, so you've done it. You've done that bit correctly. And then this is our bracket, which goes in here. And we need to factorize or solve that. We can see that this is a complex question, so it's not going to factorize. Let's use the quadratic formula to solve this. So we've got z squared minus 2z plus 10. A is 1, b is minus 2, and c is 10. So b minus b plus or minus square root of b squared minus 4ac all over 2a. That gives us 2 plus or minus square root of 4 minus 40 over 2, 2 plus or minus square root of minus 36 over 2, which is 2 plus or minus 6i over 2, which simplifies to 1 plus or minus 3i. And so our roots, we knew that z was equal to minus 2, and then we've got z is equal to 1 plus 3i, and z is equal to 1 minus 3i. And let's have a look at, so that's part A. Show on a single Argand diagram the 3 points, and then prove that these 3 points are vertices of a right angle triangle. So the way we do this, we know that our horizontal axis is our real axis and our vertical axis is our imaginary axis. So the point minus 2, that's just minus 2 on the real, so that's going to be minus 2 on the x-axis. So this is real, this is imaginary. So that's our first, let's call that z1. And that's at minus 2, 0. And then z2 is going to be at 1 on the real axis, 3 on the imaginary axis. So let's just call it here. That's going to be the point 1, 3. And that's z2. And then z3 will be vertically below that because it has the same x coordinate, but it has different y coordinate, and that's going to be z3. And that's part B. And then in part C they said show that this gives you a right angled triangle. There's a couple of ways you can do this. You could work out the different lengths and then show that Pythagoras works. The way I was going to do it, well, let's have a look. Where's the right angle going to be? The right angle is probably going to be here. Okay, so the way I was going to do it is just to work out the gradient of the line between Z1 and Z2 and work out the gradient between the line Z1 and Z3. So if I look at the gradient between Z1, Z2, that's going to be change in Y over change in X. And that gives me 3 over 3, which is 1. And then if I look at the gradient between Z1 and Z3, that's going to be change in y over change in x, and that's minus 3 over 3, and that's minus 1. Now if you look at the two gradients, 1 and minus 1, if the product of the two gradients is negative 1, which it is, then they are perpendicular, and so the angle must be 90 degrees.